Hello everyone, welcome back to the channel. In today's video, we are going to understand one of the most important concepts in AC power systems, that is instantaneous power in single phase AC system and three phase AC system, and we will see some of the interview questions. First, for analyzing single phase AC system, let us consider V is equal to Vm sin omega t and I is equal to Im sin omega t. And we know power is equal to V into I, and if you multiply Vm sin omega t and Im sin omega t, we will get this one, Vm Im sin omega t into sin omega t minus phi, where phi is phase angle of the load. And we know that equation is Vm Im by 2, and by using this identity we can write Vm Im by 2 into cos of omega t minus omega t. This one you will get phi, and in a cos a plus b you will get 2 omega t minus 5. And here you can see this first term is constant, whereas second term having some pulsating part, frequency part. First term is nothing but Vm Im by 2 cos phi, and we know that V RMS is equal to V maximum by root 2, as well as I RMS is equal to Im by root 2. So if we represent Vm Im in terms of RMS values, we know that P of t is equal to Vi cos phi minus Vi cos 2 omega t minus 5. Here this is constant part, this is pulsating part. For single phase power, graphic representation is, this is Vm sin omega t, this is Im sin omega t, this is power. And you can observe this power is having some oscillation component. So what is the frequency of power here? Here you can see it is not single omega t, it is 2 omega t. Means if voltage is having f frequency, power will have 2f frequency. This is about instantaneous power in single phase systems. Now let us analyze instantaneous power in three phase AC system. For analyzing this, let us consider three phase balanced voltage and currents, and again you consider as phase angle of load. We know VR of t is equal to Vm sin omega t. Y phase voltage is Vm sin omega t minus 120. B phase is equal to Vm sin omega t minus 240. And the corresponding currents are Im sin omega t minus 5. In Y phase, it is Im sin omega t minus 120 minus 5. In B phase, Im sin omega t minus 240 minus 5. We know here we have taken RYB sequence, RYB, and their balanced angle is 120 degrees apart. And our sequence of rotation is clockwise, like this. Now let us to calculate power in three phase. First we have to calculate power in each phase, then we have to add the entire power. As we know that in R phase power it is VR IR, Vm Im sin omega t minus sin omega t minus 5, and by using this identity omega t minus omega t plus 5, you will get this one, and you will get second term as this one, 2 omega t minus 5. Likewise in Y phase also, if you calculate Vm Im sin omega t minus 120 and sin omega t minus 120 minus 5, this is for Y phase current, and it is 120 degrees apart from R phase, and minus phi, it is same as load phase angle. Here again you take it as A, you take it as B, and you apply this identity, you will get this equation. Now if we calculate power in B phase, you will get like this, and we have taken minus 240 minus 240. Why? Because B phase is 240 degrees apart from R phase if we see clockwise direction, and you will get this. And we know that 2 negative minus 480 minus 5 you can write as 2 negative minus 120 minus 5 minus 360, and for one complete cycle you can ignore this and you will remain with this one, means cos theta minus 360 is equal to cos theta. Accordingly you will get power in B phase is like this. If we add 3 phase power, means power in R phase, power in Y phase, power in B phase, you will get this equation. This will remain in the final derivation. This one plus this one plus this one will become 0. A detailed derivation is given here. If you want, you can pause the video and go through this. I have written each and every calculation very clearly. And finally, you will get that second terms, sum of second terms as 0, and you will remain with 3 V I cos phi. This one, by analyzing this, you will get it. Here Vi are RMS values. Why? Because I have split 2 into 2 is equal to root 2 into root 2, and so Vm by root 2 becomes Vrms, Im by root 2 becomes Irms. Now let us see comparison of 3 phase and single phase powers. In single phase power you will have two wire system, that is phase and neutral. In 3 phase power system you may have 3 phase 3 wire or 3 phase 4 wire. 4 wire means R, Y, B and neutral. 3 phase 3 wire means only you will have R phase, Y phase, B phase. And you know instantaneous power is like this. Here you can see, here you will have by 2, you will have frequency component, but whereas in 3 phase power there is no frequency component. Hence you can see, let us say this is 3 phase power which is very constant with respect to time, whereas single phase power will have some oscillating component. In practical, single phase power system is used for low power applications, whereas 3 phase system is used for bulk power applications. Now let us see some scenarios in which you may get questions in your interviews. You may be attending any IIT interview for MTech admission, or GATE question you may get, any PSU job interview or any company interview, you may get this kind of questions. These are simple questions but little bit tricky. You know the question, let us see the question. In a single phase system, if voltage and current frequency is 50 Hz, what is the frequency of output instantaneous power? We have already seen in our previous slides, if voltage frequency or current frequency is omega, power frequency is 2 omega. Means let us take, if voltage in our India, if voltage is 50 Hz and current is 50 Hz, you should know that power will have 100 Hz. So 100 is the answer. If they ask if it is USA power system, it is 60 Hz, then power will have 120 Hz pulsating power. This is applicable for only single phase power system. What about three phase system? The question you may get like this: in a 3 phase balanced system, voltage and current frequency is 50 Hz. What is the frequency of output instantaneous power? What is the frequency of output instantaneous power? We know in output power equation there is no frequency component. Hence, the output frequency of output instantaneous power is nothing but 0 hertz. One more question, let us see. In single phase power system, neutral act as return path for phase current. This is load, let us take, this is source. Current will go to a load like this, and that same current will come back to source through neutral wire. What happens in 3-phase 3-wire system? This is source, this is load. If they ask like this, you should answer like this. For R phase current, Y and B will act as return paths. For R phase current, Y and B will act as return paths. For Y phase current, R and B will act as return paths. For B phase current, R and Y will act as return paths. This should be your answer. Thank you for watching. Please subscribe, like the video for more videos. Thank you.